Welcome to The Explainer, where we dive into big ideas. Today, we're talking about a type of logic that goes way beyond just true or false. We're asking bigger questions, like, could this be true? Or even, does this have to be true?
All right, let's kick things off with a little thought experiment. Think about the statement, the sky is blue. Okay, yeah, that's true, for now. But what about 2 plus 2 equals 4? That just feels different, right? It feels like it's on another level of truth. It must be true no matter what. Then you have something like, it might rain tomorrow. That's not true yet, but it's possible. So how in the world do we logically deal with all these different shades of truth?
Well, here's the thing. Classical logic, the bedrock of a lot of computer science, is super black and white. It's all ones and zeros, true or false. There's no in-between. It just wasn't designed to handle these gray areas, like what's possible, what's necessary, or even things like what we're obligated to do.
So to tackle this, logicians realized they needed a whole new toolkit. They needed something more flexible, something that could open up completely new ways of reasoning about the world. And that's exactly what they came up with. It's called modal logic.
And this is where modal logic steps onto the stage. It's a formal system, but don't let that scare you. It's basically a language built from the ground up to handle these different modes of truth. It lets us be super precise when we're talking about what's possible, what's necessary, what we're supposed to do, or even what we know for sure.
Okay, so what are the tools? At its core, modal logic gives us two new symbols, two new operators that are super powerful. First, we have the box. When you see a box in front of something, it means it is necessarily true. Think of it as putting something in a box of absolute certainty. So, box, 2 plus 2 equals 4, means it's true no matter what. Then we have the diamond. The diamond means it is possibly true. So, diamond, it will rain tomorrow means, hey, it could happen. There's a chance.
So how does this actually work under the hood? This is where it gets really cool. The big idea is something called possible worlds. Just imagine our reality right now is just one world. But branching off from our world are tons of other possible worlds. Worlds where things could have gone a little differently. Now, for a statement to be possible, our little diamond symbol, it just has to be true in at least one of those other worlds. But for it to be necessary, the box symbol, it has to be true in every single one of those reachable worlds. It's a pretty mind-bending but powerful idea, right? And that's why 2 plus 2 equals 4 is necessary, because it's true in all of them.
Okay, now that we have this key, this idea of possible worlds, we can unlock all sorts of new logical universes. Let's go on a quick tour, because you're going to see how this one simple framework can be used to reason about everything, from ethics and rules to the nature of time itself, and even to the world inside our own heads.
First stop, the world of rules, of obligations and ethics. How can you use logic to talk about what you should do?
This is what we call deontic logic. It takes that same box and diamond idea and applies it to things like obligation, permission, and prohibition. It lets us build formal systems of rules. For example, a really fundamental principle is, if something is obligatory, then it must also be permitted. And that makes total sense, right? You can't logically be required to do something that's forbidden. It's a contradiction.
All right, let's jump from rules to time. Because think about it, the truth of a statement can totally depend on when it's said.
This is temporal logic. And yep, you guessed it, it uses the same modal operators to reason about time. You can have operators that mean it was true at some point in the past, or it will be true at some point in the future. And this is unbelievably useful, especially in computer science, for verifying that a program does the right thing at the right time, or even for analyzing complex legal contracts.
And now, for our final stop, we're going to the most complex world of all, the one inside our own heads. We're talking about the logic of knowledge.
This is where the power of modal logic just shines. It's called epistemic logic, and it gives us a formal language to talk about what someone or something, like an AI, knows or believes. You can even get super granular and distinguish between what is theoretically knowable out there in the universe and what a specific person or AI actually knows. And you can see how this is absolutely essential if we want to build and, more importantly, understand intelligent systems.
So you might be thinking, okay, this is a really neat philosophical puzzle, but does it have any real-world use? Oh, absolutely. It's not just for philosophers anymore.
The truth is, modal logic has quietly become one of the most important tools we have for building the future. It's the engine running behind the scenes in so much of the advanced tech we're starting to rely on every single day.
Here's the bottom line. Modal logic is a game changer for automated reasoning. I mean, think about it. If you have a giant AI model with a knowledge base the size of a library, how do you make sure it's not contradicting itself? How do you verify that it's all logically sound? Well, you use these formal systems to check for consistency. It's what helps us make sure these complex AIs are reliable and don't go off the rails.
Okay, let's zoom out. What's the big picture here? What's the one thing you should really take away from all this?
The main takeaway is just how elegant and powerful modal logic is. It's this beautiful, unified framework that takes our reasoning abilities to a whole new level. It gives us one set of tools to think clearly about all these different things: possibility, time, knowledge, ethics, all the messy, complicated stuff that makes our world so interesting.
So in the end, by giving us a way to formalize these ideas, modal logic doesn't just help us build smarter machines, it actually helps us understand ourselves better. It sharpens our own thinking. It expands our whole mental toolkit. Which leaves us with a final, fascinating question. We now have logics for what is, what could be, and what must be. So what should we build a logic for next?